So, good afternoon, everybody. Thank you for joining our webinar today, which focuses on circular economy and wastewater treatment sector. My name is George Alidis, and I will be one of the hosts today in this webinar with Gijsbert Korrevaar and Jan Willem-Melder, who are presenting, and also my colleague in ISPT, Kees Roest, is the co-host, and as well Daniela Kutka and Josh Franklin from Revolve Media. The aim of the webinar is to promote circularity in the sector and industrial symbiosis among corporations, and also improve capacity building and support by the online BRINE platform, which I'm going to discuss later what it is and how to use it. As a result, we have classified today's webinar in 3 sections. The first is about circularity, circular economy, industrial ecology, and industrial symbiosis. And Gijsbert Korrevaar is presenting, as well as who comes from Delft University of Technology, and Jan Willem-Melder, who comes from Evides Industriewater. Then the second part is about the Zero BRINE project, what it is and what it is about, quite briefly. And the third part is about the online BRINE platform. Between the sections, we're going to have 2 breaks. And I have also prepared some polls, which are multiple choice questions in order to get some feedback from you, and as a result guide the presentation, the webinar in a way that becomes more interesting for everybody. The replies to the polls are anonymous, and the whole webinar is going to be recorded, but it is not for commercial purposes. It is only for to make a report out of it due to the European funded Zero BRINE project. Lastly, there is going to be a questionnaire which is going to be presented briefly, part of it, and then the rest is going to be distributed. And I hope that everybody fills it in and sends it to us so we can get some additional information about what you think about today, but also about the online BRINE platform. When I will be talking later on, you can interrupt me whenever you want. Otherwise, during the whole webinar, you can also write down comments in the chat section. And I hope to have an interesting webinar today. So, as I said, the first 40 minutes are going to be about capacity building, where Gijsbert Korrevaar and Jan Willem-Melder are presenting. Then it's going to be about the Zero BRINE project, description and results, then a break, then the online BRINE platform is going to be described quite in detail with a tutorial, then another break, and then finally have the questionnaire and discuss about the online BRINE platform, and finally wrap up. So my name is George Alidis. I'm a mechanical engineer by background. Then I came to the Netherlands and I studied industrial ecology, and I started a PhD in TU Delft about process engineering, but also about environmental assessment of refineries and biorefineries. Then during my postdoc, it was the first time that I came in contact with the Zero BRINE project, and I worked for it for 2 years, and I continue doing so. Now from ISPT and also from Silo. And during my postdoc, I focused on the environmental assessment of Zero BRINE demonstrations demo units with life cycle assessment, the social performance with social life cycle assessment, and the financial performance with life cycle costing. And with this, I would like to give the floor to Gijsbert Korrevaar for the first part of the webinar today. And also, Gijsbert, you have control of the presentation. Thank you.
Okay, thank you, George, for giving me this platform to tell about this topic of circular economy and industrial ecology. And some of you might know my name or might know my face from the Zero BRINE project, although I realize that not everyone is familiar with the Zero BRINE project. We will talk about that later this afternoon. But in that project, I'm occupied with the sustainability assessment, but actually in my daily life, most of my research is focused on what we call industrial symbiosis or circular economy. And as you can see in this title slide, I played a bit with those two names because it is about the symbiosis of circular economy and industrial ecology. And so I also realized that in some of my presentation, there's quite some new terms and concepts. So bear with me, I hope to explain them. And now if you do have questions, then of course, raise them in the chat, or we can also later have a discussion after the presentation. Let's see if my control works. Now I'm suddenly out of the presentation. It was not what I intended to do. Okay. So a bit about my background. George did it as well, and I think it's good to have some background of the speakers of today. So my position is an assistant professor in TU Delft in the Faculty of Technology, Policy and Management, and we do have a department on engineering services and systems. That's all a mouthful, but it mainly means that the research that we do is technical in nature, but it also really takes into account societal and governance and management aspects as well. And that is typically something that is needed for a circular economy. That's also important for an industrial ecology or an industrial symbiosis approach. I will show that later. And you also can see that in the things that I have done or that I'm still working with is that I'm a chemical engineer by training. So I know a lot about process engineering and about water treatment systems and water management, but also about feedstock and fuel resources. I also did a lot in the field of what we call industrial ecology, with a specific focus on industrial symbiosis. And recently, I also started to work, and then recently in terms of the last 3 years or so, work more and more in the field of circular economy. Now, and I hope to explain in my presentation today also how those concepts relate to each other. So I try to find, let's say, an image of how you could say what the starting position is if we talk about circular economy and why that is an important aspect, and also why we should present that actually today. And for me, this is still an interesting overview slide. It actually comes from a KIC program that we're also involved in, and the KIC program on climate change. And KIC stands for Knowledge Innovation Centers for the European Union. So we have this consortium of many institutes and companies in Europe working on climate change. And there we always say, well, it is sustainable growth across the value chain. That is what we intend to do and what we like to do. And if you talk about sustainable growth, that means that, we basically can see growth, or we can see development in several aspects of that value chain. So we could, for example, focus on the future feedstocks that we might want to develop or that we might need. And then feedstocks, you can think of course, raw material resources, but also feedstock for fuel and new types of fuel that we are thinking of, but also if we focus specifically on what the Zero BRINE project wants to do, the recovery of minerals from wastewater, that is also a kind of finding new feedstock. Future products is also something that we like to develop. If we say, well, sustainable development is not something as just going back and doing the things of the past, but also that new types of products and applications might be needed. And in order to basically connect the fact that we might want to use future feedstock and might have future products, there's also what we need, across industry efficiency. So that industries that are normally in perhaps several locations or sometimes just standalone operation, that those industries also have more of a connection with each other, and that they are able to share resources, share knowledge, share energy, and so on, infrastructures if needed. Now that combination of cross-industry efficiency and new feedstock, you could say that is the shortest definition of what we call industrial symbiosis. And so that the industry is much more in a symbiotic system, an ecosystem, in which resources are shared, in which new types of feedstocks are developed, new types of products. And that also has a link with what we call circular economy. And circular economy is more than just the recycling of materials. It's really the local economy that becomes more circular, so that wastes are used as new input, or that byproducts are not turned into waste, but are used as an exchange to other locations. That also products, after they are used, so at the end of life, are used again as input. So that entire idea of circular economy, you could say, binds together the other three aspects as well. What I also find important in this image is to say it is about sustainable growth. So that means that in all those 4 items, we can still grow. And that doesn't mean that just unlimited growth is necessary. If we do that carefully, we can still have an economic business growth, and at the same time contribute to lower environmental impact, and in that sense also more sustainability. This presentation that I do today is, you could say, it's kind of a mini lecture that I give you, also with the idea of, we will present the online platform later. We also will hear the story from Evides, so we will have a practical case study. So I stay a bit more on the theoretical side, and I thought, well, it is good to have, well, some elements available also for later discussion. And one of those elements is that if we talk about sustainable development, or we talk about the transition to a circular economy, that in this kind of wording, development or transition, we talk about what we call system changes. And system changes comes in several levels. And this might be quite obvious to perhaps most of the audience, but I think it's still good to mention that if you talk about the changes we need for sustainable development, that you could have that on an, you could say, lower level or a more detailed level, and you also could have that on, well, system changes on a larger scale. And you see that in this picture. So if you go from level 1 to level 4, then level 4 is a higher system level, meaning it takes into account more complexity and it is of a broader range. So in level 1, you see it's about process changes. And I think that if you simply look at, well, most of the operations that we do in Europe, and especially also in the Netherlands, that most of the processes we have developed and that we are operating at the moment, they already have made many efficient and effectiveness changes in the past. And so we don't have to teach the industry anymore that you can also save energy, or that you can reduce the energy, or that you can improve the energy efficiency, so that you can reduce, for example, the fuel consumption. Most of the companies do that also for economic reasons. So that means that level 1, and you see there an abbreviation CP, stands for cleaner production. That cleaner production and process change is something that is quite obvious for most of the industry. But if you talk about circular economy and industrial symbiosis, then also level 2 and level 3 are important. And then it's not only about to make the process, the factory more efficient, but that we also make the value chain more efficient. That we have improvements along the value chain, but also might have improvements in the organizational side of that value chain. Now you see that level 2 and 3, I think, are the most dominant in most of the discussions in circular economy. So then it's really about, and as you see here again, many abbreviations. I'm not going to read them all aloud, but it's like life cycle assessment, LCA. It's like environmental management system, EMS. So those are concepts that help basically to also change the systems on a higher level. And then you see also level 4, in which we say, well, it's not only the industry that might have to change, but it's even the system around the industry. And so the consumers that actually take the products of the industry, or the government that makes regulation and do legislation for the industry. That's more the system changes that even go beyond the organizational change and the product change in the value chain. So level 4, and you see then abbreviation like industrial equality, IE, or CSR, that's corporate social responsibility. Those are things that even go beyond the typical industrial activities. Now, if we talk today about what do we like to basically achieve in a project like BRINE and with a platform that has been developed, then you could say it's towards level 4, but mostly it's about level 2 and 3. And it's good to keep that in mind, that we are talking here about changes that are not just in the processes, but also go beyond that. I already talked about sustainable growth in a previous slide. If you talk about that, and there's always a debate, we can have that debate today if you wish, but I think that most of the people are now already have passed that debate, but there was always that debate of sustainability means it costs a lot of things and it is against growth or something. Sustainability puts limits to an unlimited growth of the economy, but it is not true that sustainability in principle means that you cannot grow or that it is bad for business. You can imagine that if you would have a very polluting operation and suddenly there is environmental legislation and you have to adapt that process at once, that it costs you a lot of money. But if you know in advance what a sustainability regulation will be, and you have time to basically change, then you see that most of the companies are very much able to basically adapt themselves and to make sure that economic growth and sustainable growth go hand in hand. Now, in the background of that argumentation is that we actually are trying to achieve a kind of decoupling. So in the traditional economy, we would say, well, there is more economic activity, there's more people, and that all leads to a higher environmental impact automatically. And the more wealthier a country is, and we still see that trend, more wealthy countries, more economic turnover, more GDP, means in practice higher environmental impact. However, if we do that correctly, and if we use the tools for circular economy and industrial ecology, we can decouple that economic activity from the environmental impact. And that's the idea of decoupling. So we like to decouple that economic activity, economic growth, from the immediate rise in environmental impact. It might be that it's just on my computer, but it seems that I lose some of the bottom of my slide here. But anyway, I can still explain that. So we have, what I'm now doing in this presentation is I'm trying to settle a couple of ingredients that are interesting and necessary for having a debate about industrial symbiosis and circular economy. And there's one other thing. I mentioned already the system layers and the system levels, but there's also another way to look at what we call the complexity of systems. And that is that, and you see that on this slide, is that you also can really put an institutional perspective to systems. That you say, well, actually, if you look at the complexity of our society, that it is institutions embedded in other institutions. So you see that here. You see that on the level 4, the layer 4, there are market activities. So that is companies that make decisions on what they want to produce and what the prices are, the quantities. Then on top of that, there's an entire organizational layer that says, well, this is the way in which you write a contract. This is the way in which costs are developed or market arrangements are done. Then on top of that, there is a governance layer of, well, you see that of laws and rules and industry standards. On top of that, there's all kinds of formalities. They're sometimes so obvious that we don't see them, and sometimes might be interesting to work in another culture for a moment, and then you suddenly realize that things like this is the way how we normally do that in our country, that it is still quite unique, or that is something that has been developed in many years, and everyone is well used to that. You don't just take land from each other, or you don't just increase the price without any information. There's a lot of institutional rules behind that, and even then the top layer of norms and values. There's something like good business behavior, or that's something like you have to act as a gentleman. But where does that come from, and how is that actually ruled? Now, what this scheme actually suggests, and you see the title of the slide, that this is an what we call a comprehensive method for the design of, in this case, energy infrastructures. It is described like that because it has an it comes from a publication of one of my colleagues that is working a lot on energy infrastructures. So if you want to understand how energy infrastructure works, then it is very helpful to have this institutional perspective. That if you, for example, want to say, is it possible to have a heat exchange network, or to go for the heat transition, then you can use this scheme to understand where also bottlenecks are. If you go from top to down, we just went bottom up. You can also go the other way around. You could say, well, if we go from, in the Netherlands, for example, from a gas fueled energy system to a heat exchange network, so heat transition, how does that actually fit in the things that we normally do? How we heat up our houses, all kinds of traditions there. What is actually the current law? What is the current sector that is involved? What kind of contracts do you have to make? And what kind of decisions can companies then can make? So that works for energy infrastructures, but it definitely also works for all kinds of, let's call it material infrastructures. So if this would be about industrial clusters and industrial ecosystems, then you could have the same kind of argumentation. I've been talking about those industrial networks already a little, because, well, I mentioned it now and then, but it's good to have an perhaps even more precise picture of what actually an industrial network is. And you see this slide is that we have different types there. You do have what we call the pure agglomeration, which you say, well, that's just industry sitting in the same location because they have the same address. So they simply are placed there because the government wants the industry to be in an industrial district. That is a pure agglomeration, and the companies in that district might not have much interaction, but are simply there because of planning issues. There's also the industrial complex, and I think most of the companies that are involved in a project like Zero Brine, or also with the example that later on is presented by Evides, that is more part of an industrial complex, and it's already, there is quite some interaction between the companies. Wastewater is treated, there might be a steam network, there might be a hydrogen exchange. So there's all kinds of industrial activities that are already exchanged besides just the products that go from one producer to the next manufacturer and so on. So in an industrial complex, there's already a lot of material exchange. And then we also do have this other extreme of saying, we do have a network of companies, but they actually do not exchange so much of material, but they more exchange knowledge and information. And we call them a social network. And the most obvious example for that is Silicon Valley. That is full of tech companies. They all develop all kinds of new apps and applications, but there's only a less, you could say, material exchange. The devices itself, the phones and so on, are even not produced there directly. It's much more a social network of people that have, well, but they are in competition, but they also exchange a lot of information with each other. With all that in mind, that we say, well, if we talk about circular economy and industrial symbiosis, we're talking about a technical design that is okay, someone asked me to, perhaps I need to put on my phone. Okay, sorry. Yeah, if the sound is not good, then I can change that.
Yeah, I hear you very well, but I also got notification that someone hears some background noise, but I hear you very well. Okay,
now then I just leave it like this, because if I'm now going to change, it also might take more time.
Yeah, no problem. Yeah, thanks.
Yeah, so in that entire complex of that we are designing technical things, but at the same time keep in mind that there's different layers and there's a complexity of society. Now, people have talked about what we call the transition design theory, and this might be well, a picture with many boxes, but you basically can read it as that you follow the fat arrow down and up. And so you see here what this method does. And it's not only a picture, of course, there's an entire manual behind it, but I'm not going to explain all the details right now, but you can ask me later. But what it does is that you first describe your design problem as a societal problem. Then you look into what the system needs, and you go all the way down to the product design. And after you have come with your new creative product design, you take into account the levels again, so that you in the end can check if that new type of design that you came up with is actually embedded in all the different layers and levels. And that's a very interesting new approach. That means that the typical product design is not anymore, well, someone wants me to make a new product, a new laptop or so, and that's it. No, I look to all the complexity that is around it and take that into account. And that approach can be used for any kind of technical or engineering design. So to give you an example, we apply that in a situation with a cable manufacturer. So the Dutch cable factory, which is actually located in Delft, and but they are part actually of the multinational Prysmian. And that was a very interesting example of, they say, well, we want to produce new cables, and we want to do that in a circular way. But one of the first things, of course, you come across then is that if you want to produce the cables now from the cables that were produced 30 years ago, you already might have a problem that the cables 30 years ago were not ready for recycling. And so that's already one of the things that you immediately, let's say, feel if you do circular economy. And then, of course, the next step would be that you say, well, then I design the cables right now so that after 30 years, I might be able to recycle them. But how does actually the future in 30 years, how does it look like? Do we then still need the kind of cables that we are now developing, or do we have smaller cables or more cables because of more electricity? There's a lot of electrification going on, so perhaps there's a massive amount more of cables available then. So how do we do that? So how do we take into account that there's many system changes ahead, and at the same time we try to make our cable production right now more sustainable. And there you see that this example of just simply producing an electricity cable immediately leads to the necessity of understanding the complexity of the energy transition. That's not only the cable anymore, it's even, you have to understand how the energy system will look like in the coming 30 years and how that influences your production at this moment. Now, the same is true for, you could say, because that was again an electricity and energy system example, but the same is true for what we call an industrial symbiosis. So if you talk about the mass flows and the processing in industrial clusters, you see the same principle applying, is that we have several economic activities. There is current use of that activity, there is new production needed, and so we have to develop not only the new processing unit, but also the availability of exchange of material, the sharing of services and infrastructures, the byproduct exchanges. That is also needed to bring the, you could say, current operation to a next level in which more exchange is taking place. And so that means that in industrial symbiosis, there's many topics that are actually related. And this is again a long list that also might be of use later if you see the slides. But it's also to illustrate that industrial symbiosis is not only about waste exchange. It needs process intensification, new types of infrastructures, all kinds of diversity, but also the organizational embedding. And so industrial symbiosis is really all the things that are related to resources, production, transport, waste treatment, and that all linked together with a mutual benefit. There's one remark that I also wanted to make about the circular economy that is very nicely presented in this picture. What you see here is the entire circular economy of the EU 27 countries, 27 countries in Europe. And you see here numbers in gigatons. So those are massive amounts of material that you actually see in this one picture. And I already highlighted that a bit with my example on the cable producer. But that is that you see that a large part of all the materials that go around in Europe, they actually end up in a stock, which is very obvious, by the way. So that simply means that we produce something and it goes into houses and cars and ships and factory halls and whatever. And it simply stays there, of course, for quite some time. It's not so that you produce something today and it will be recycled tomorrow. Most of the products that we have last for a couple of years or sometimes even decades before they are coming back. And so you see that this amount in the stocks is quite dominant. And it's also something that we have to keep in mind. If we talk about circular economy, we're talking about, well, taking stock from the past. And sometimes we also need to explore and to find out how much is in stock and how much is available. So you see that in the world of circular economy, you have many different approaches. I'm not presenting that today. I just always like this picture. Came from a PhD thesis several years ago, in which one of the students basically compared all kinds of frameworks. And you see that circular economy comes in many variations. You might be familiar with this one. That's called the think tank of Ellen MacArthur Foundation. They have this butterfly diagram. And no, but there's actually many more variations of that. I'm not discussing I'm not discussing right now what is the best framework or what should we choose, but it's good to keep in mind that in the debate on the circular economy, there's still quite some variation possible. Now, I would like to close with this slide. Then I spent just 30 minutes, I think. That is, if you see this slide, then you see on the left side, you see industrial ecology. And some part of industrial ecology is industrial symbiosis. And that is actually the idea of that companies at one location exchange material with each other. And then in that way, well, increase the eco-efficiency and being more eco-effective. And at the other side, you see circular economy that has more or less the same assignment, you could say, the same philosophy. The practical difference between the two is that circular economy is also focusing much more on different types of business models. Yeah? So new business models are developed in the field of circular economy. And so you see that symbiosis has more the focus on what kind of different dynamics and transition dynamics exist, and circular economy focuses more on the business models. That's what I wanted to present today. I already saw that Kees asked for questions. So I'm happy to take questions now, but we also could say, well, we first do the presentation by Jan Willem, and then we take questions together. But that's up to you, George.
Yeah, if there are no urgent questions, please ask. I have a question myself to Gijsbert. Industrial symbiosis, how close do you need to be? Is it also possible to have the symbiosis if you are like hundreds of kilometers apart?
That's a good question, because let's say that mostly might be a matter of transportation. Eh? So let's say in the original publications about industrial symbiosis, so 20 years ago, people were very strict in that they said, well, it's not industrial symbiosis if they are further than, for example, 5 kilometers away. So you needed proximity. That was the discussion. Now we already realize, of course, that, for example, if you take a cluster of Rotterdam, you already have more than 5 kilometers in the cluster. If you, for example, then also take a combination of Rotterdam, Antwerp, for example, as a kind of industrial hub, then we're already talking about 100 kilometers. And you see now more and more in the discussion that, yeah, in the end, of course, it is a matter of, can you see that the transportation emissions, for example, really play a role? If we talk about transportation over sea and that goes to Rotterdam or Antwerp, which actually doesn't make a difference if you come from Brazil, then also you could say the connection between the two clusters also might not be of a big effect on the emissions. So we now see that a more open debate exists and that people also see industrial symbiosis, for example, in one country or that in one region. But in the end, of course, we always need kind of before and after sustainability assessment, so that there is, of course, examples in which the transportation really plays a very big role, and then you have to be as close to the source as possible.
Yeah, thank you. So if all the people have questions, please use the chat, or sometimes we have also a Q&A like now. So if you have a question, let us know. And
thank you, Gijsbert.
Continue with the next one, and then
thank you, Kees. Yes, Jan Willem. If there are no more questions, Jan Willem, you can continue with the presentation. Thank you.
Thank you, George. So in the coming 10 minutes, I'd like to introduce what circularity means for Evides Industriewater as a water company. I guess I should be able to. Yes, it's working. Thank you. First, our mission statement. Evides is a water company, of course, and our mission is that we offer water solutions, reliable and innovative. Before I focus further on circularity, it's good to know who Evides Industriewater is and what our activities are mainly. So we are active in the supply of industrial process water, and that can be any quality that an industry is wanting. It's mainly demi-water, and 1/3 is even polished demi-water up to ultra pure. We do that mainly by DBFO or commodity. That means that we are in charge of the installations. We are the operator, and that's a very important fact also when you consider the possibilities for circularity. We are also active in wastewater treatment. Water reuse, of course, is more and more actual nowadays. And as last point, we are also do activities in cooling tower water. So circularity is becoming more and more important. We started a program under the name Water Without Waste. We started with a very big ambition and the first title was Zero Waste, but we realized that zero waste is really difficult to reach. So the whole program is now under the name Water Without Waste. And we consider sustainability in many aspects. So we, like other industries also do, we started with carbon dioxide reduction. Climate change, carbon dioxide, everybody's working on that nowadays. But there's more on that. So water depletion is also more and more an issue. You have to realize that we are active in some regions where fresh water availability is not so for self-speaking anymore. Mainly the southwest part of the Netherlands, Zeeland, Zeeuws-Vlaanderen as regions. There's a lot of water there, but most of it is saline. And fresh water availability is going down more and more. So we also aware of the fact that we also have to do something about the question, is there enough water and can we save water, can we reuse water? But our program Water Without Waste is going further. An example, biodiversity is also part of our program. It's not directly related to water activities, but of course we have sites and we have area in our possession. And when we plan a new water factory, for example, we also have to think about how to have the area around it. What can we do during the construction and also afterwards to preserve biodiversity? We are certified by Evides for sustainability. At least in 2019, and we are at this moment active to have the certification extended. And we're also working on the 14001 ISO certification. So a lot of activities within our organization to have sustainability very active in our working processes. We also adopted life cycle analysis tools. That's something we started this year. And I have to say the first sessions to have LCA analysis, it teaches us a lot. There's a lot more than just carbon dioxide, water depletion. There are many aspects involved in the LCA tool. So we are at the beginning of the period of learning, I have to say. Circularity, what are we doing about that and what did we do so far? During the last decade, 10 years, maybe even more, our main focus was on water reuse. And we have some nice examples within our day-to-day practice of water reuse. The most obvious is a reuse project, what we do for Douwe-Terneuzen. It's in the southwest part, where a lot of water is saline. And that project was started because Douwe had the ambition not making use of water that also can be used and is actually used as a drinking water source. Now we have a big pipeline for fresh water supply to that part of the Netherlands. Water is coming from big reservoirs in the Biesbos area, but the water is used for both industrial water and for drinking water production. And now has the ambition and has the philosophy, we don't want to compete with those kind of water sources. that can be used for drinking water production. So we started together thinking about options for water reuse, and we ended at the local water authority. And nowadays we use domestic wastewater as part of the water source, not entirely, of course, but part of the water source for the demi-water production for DAO. And we intend in the future to extend it to have a bigger amount of water being reused. Together with the same client, we also reuse the industrial wastewater. DAO has its own wastewater treatment plant operational, and the treated wastewater is reused, is treated by us and reused as a cooling tower water supply. So together with the domestic wastewater reuse, we have quite a nice example of water reuse there. A more recent example is wastewater of Lempes de Meijer in Kruiningen, also in the Zeeland area. And Lempes de Meijer has also the ambition to reduce their water footprint. And starting with their own wastewater treatment plants, we constructed a reuse plant for them. It has been operational now for 1 year, and we reuse their own wastewater for their processes. A difficulty is Lempes de Meijer is a potato processing industry. So we are dealing with the food sector, and wastewater reuse and food production is always a little bit difficult. And for that reason, so far the water is reused in their boiler feed and other non-food applications. But the discussion is going on. When are you allowed to reuse wastewater in the food industry when it's also being in contact with their products? So the discussion is going on not only with this client, but it's more broad in the Netherlands going on at the moment. We do more on circularity in the meantime. We have 2 projects for heat recovery. One of them is heat exchange in the Botlek area. What we do there is heating up the incoming water for demi-water production. And when you realize that the demi-water that we supply to the clients mostly is used for steam production, when we heat the water up, the energy input for the industry will be lower. And the heating up is done by waste heat that's produced by the same industry. We have also another project, slow warm glisting it's called. It's a heat exchange project where waste heat of the Zeeland refinery is being used for other clients. So that's a dedicated heat project. Of course, there's more in circularity. We have to think about recovery of resources. At the moment, it's mainly part of our R&D program. The main projects that we have at the moment going on is the Nereus project. It's a project where we treat domestic wastewater, but not with the traditional techniques, but with alternatives. We start with sieving, electrocoagulation, but in the meantime we changed it for iron chloride dosage, nanofiltration, and the aim there is to recover and reuse all kinds of resources from the domestic wastewater, like cellulose, phosphorus, nitrogen, humic acids, energy, but of course also the water at any quality that's needed. The new research for electrochemical recovery of ammonia. We have several pilot plans and pilot trials for reusing effluent for water reuse, of course. So mostly domestic wastewater effluent. And of course, the Zero Brine project, where we recover minerals from the brines. In this situation, the brine flows from our demi-water production plant in the Botlek area. So resources at the moment mainly part of our R&D program, but not yet. Then I want to, but how can I go back one slide? Maybe, yes, thank you. I think my connection is a little bit slow, so I hope you still can hear me. My conclusions and future developments. Environmental impact, we discovered so far it's a mix of many aspects, and we discovered that in the LCA analysis. So there's a lot to learn for us. We are convinced that circularity is growing, and it will grow in the future. And it will be the common practice maybe in 10 years or 15 years. Looking for opportunities in the value chain is important, but you really need cooperation, like the example with the Dow chemical industry, with the water authorities. So circularity, doing by your own, I don't think the chances are very high. You really need a cooperation in the value chain. And my final conclusion, there's still a lot to be developed. So with that, I want to conclude my presentation, and maybe there are questions.
So in the chat, I did not yet see questions, but if someone has questions, please step in now and feel free to ask. So one of the things I learned that is without waste is not zero waste.
No, zero waste is an ambition too high, but when we started, we said to each other, we should state an unreachable goal, and any step that you can make towards that goal is a profit. But finally, we left the idea of zero waste and then started the water without waste. I have to say, it's a combination of what our ambition is and also the client's ambition. And we see more and more that clients have the ambition to be sustainable, to reuse water, to reuse other resources. But finally, someone has to pay for the technique you install. So,
yeah, it's a good ambition. There's a question in the chat. Maybe the person would like to ask him or herself. Yeah, here.
Can you tell us more about what technologies Evides R&D focus on revoking minerals recovery? At the moment, the mineral recovery is mainly in the zero brine projects. It's a combination of several techniques, and I can mention maybe not all of them, but nanofiltration to have a separation between mono and multivalent ions. We have evaporation, making use of waste heat to thicken the concentrated brine flows, to make even demi-water out of it. There's a crystallization process to recover calcium and magnesium hydroxides separately from each other. We have an EFC at the moment, also operational to separate solid salts and water. So it's a combination of many techniques.
And I will also present all the technologies in,
I'm sure.
in the case studies later. So yes, the rest, you mentioned almost everything, but yes.
Okay, thank you. If there are no other direct questions, or feel free to ask, but use the chat for that as well. Otherwise, thank you, Jan-Willem and George. You can continue.
Thank you, Kees, Jan-Willem, and Gijsbert. Okay, so the next section, until for the next 20 minutes, I'm going to present you the Zero Brine project, which focuses on wastewater treatment. And as Jan Willem presented earlier, fresh water and drinking quality water is not abundant. So here in the Netherlands and in most towns, cities in Europe, we can find good quality drinking water everywhere, but this is not the case for the whole world. As a result, it's crucial to use as less as possible drinking quality water. And for this reason, one of the Sustainable Development Goals is focusing on water and sanitation. And next, I would like to show you a small video. Okay. About that, so I will share my screen, and I will make sure that yes, there is computer sound. So water and sanitation, sustainable water and sanitation is very important, as you saw, and the United Nations have dedicated one one sustainable development goal for that. And at this point, you have heard a few things about zero brine from Jan Willem and Gijsbert. So I would like to ask you if you have heard before this session about zero brine. So if you can please fill reply with a yes or no. Okay. Okay, I think more or less. So I have to be also a bit quick. So 80% of participants of you have already heard about zero brine, and 3 of you have not. Okay, that's good. So we're making a good job in communicating the project and its results. So in the next slides, I will present briefly zero brine. So first, I will talk about brine and what is brine. So brine is water which has a very high salinity level. Usually, salinity comes from sodium chloride, so our common salt, but there can be also other kinds of minerals that exist in the water, in the briny water. And brine has a much higher salinity than seawater. Brine is generated in the Netherlands, and at the same time, Netherlands is lucky in a way because it is next to the ocean, and there are big ports with big industrial clusters. So in some cases, and depending on the minerals, on the materials that exist in the brine, the companies can dispose briny water in the ocean before or after dilution with water. As a matter of fact, every year 650 kilotons of chloride releases are happening in the Netherlands, and this regards only the chloride releases. As you can imagine, brine can be up to 10 or more times more than that. So Zero Brine, it's a European funded project from Horizon 2020. There are a lot of partners which are part of the project. And some of those partners are large industrial process industries. For example, Evides Industriewater, which is located in the Netherlands. And there are 4 case studies, 4 process industries that are generating large amounts of brine, and these process industries are different. For example, there is a textile plant in Turkey, a coal mine in Poland, an ultra pure demineralized water plant in the Netherlands, and a silica plant, precipitated silica plant in Spain. The important aspect of Zero Prime project is that for each of the case study, for each of the process industry, demonstration units are going to be built, and they are going to process real brine produced from those industries. Next to that, brine excellence centers are going to were built, were developed, and these brine excellence centers, BECs, they exhibit the same, they demonstrate the same technologies which are part of the case studies in bench scale or pilot scale and I will talk in detail more for each case study. So as I said, there are 4 case studies. The textile plant in Turkey, where there is already a reverse osmosis unit in order to treat their wastewater. because they use salt in several cases, especially when textile is dyed, when they are painting, where they're giving color to the textiles, the products. There is a coal mine, and brine is produced in underground coal mine while coal is extracted. And this is very important because brine is not only produced from active coal mines, but also abandoned coal mines continue to generate brine. And as you can imagine, this becomes also important in an energy transition context where less fossil-based, coal-based electricity is going to be generated. These mines are going to close, but then brine will continue being generated. Then the silica plant in Spain, and in this case, the company is consuming fresh water up to 10 or 50% on a regional level. And then finally, the Dutch case study where Evides Industriewater is producing ultra-pure demineralized water for the nearby industry. And in this case, salt is purchased, high purity salt is purchased and transported from the northern part of the Netherlands. And as a result, salt is used in order to regenerate ion exchange membranes. And because of the quality of the brine that Evides Industriewater is producing, and also due to the regulations, and also the location of the plant, which is next to the sea, next to the ocean, Evides is able to dispose brine to the sea. Right now, Evides is consuming surface water, and then it is being processed with a flotation and then with ion exchange softener to clean it and to remove some minerals, and then it's further processed with reverse osmosis, and finally it is polished in a mixed bed, and then it is distributed to the system. So you have heard a few things about the Dutch case study, and you know about the location of the plant, also about the Dutch regulations for that location and that brine, and also in relation to the salt that it is used. So I would like to ask you if you can imagine what kind of environmental benefits you would expect due to the Zero Brine project. Because the purpose of the project is to treat the brine and to recover minerals and clean water, which can be reused internally by Evides, or they can be sold to other companies who find it relevant. Okay. So you said you mostly replied 70% that environmental benefits are to be foreseen, but also cost benefits. This is true. The environmental benefits, which I'll also show later, is mainly due to the expected toxicity. And then cost benefits can be foreseen because less salt is going to be purchased from the northern part of the Netherlands. However, also social benefits are expected, and I will explain later why. It is mainly due to the magnesium hydroxide, which is going to be recovered. So if I close this, then go to the next. So somebody asked earlier, Jan Willem, about the technologies. So, excuse me, brine is generated from two sides, the ion exchange softener and the reverse osmosis unit. And as you can imagine, this brine has different characteristics, and as a result, different technologies were selected to process brine from site 1 and site 2. In both cases, a pilot demo scale units were operated, and in site 1, nanofiltration, membrane crystallization, evaporation were used in order to recover high purity water, clean water, high purity magnesium and calcium in the form of magnesium hydroxide and calcium chloride, and magnesium hydroxide is currently mainly imported from Russia, Far Eastern Russia or China. And in the case that it is imported in Europe from Russia, then it's considered a conflict mineral. And I will also mention later that EU wants to reduce this kind of minerals imported to Europe. And from the second site, a NIAX equipment is going to be used to remove the total organic carbon from the brine, and then nanofiltration units, reverse osmosis, evaporation, and eustatic freeze crystallization is going to be used, were used to remove sulfate salts, sodium bicarbonate, clean water, and in both cases, a solution, a regeneration solution rich in sodium chloride will be recovered in order to replace the high purity salt. The second case, it's about the Spanish silica plant. And in this case, the slide regards only the zero brine system, the demonstration unit. And in this case, brine produced from precipitated silica production and sodium silicate is going to be treated with ultrafiltration and reverse osmosis, which is going to employ regenerated membranes. So in this case, another aspect of circular economy exists because spent membranes are going to be regenerated and reused instead of just disposing them. And then sodium sulfate, and then finally there is a eustatic freeze crystallization to produce sodium sulfate and pure water. The pure water in this case is also expected to replace feed water, and the sodium sulfate, depending on its quality, can be sold with a considerable turnover. The third case about the coal mine, and the coal mine right now is disposing the brine to a river, but the plan is to stop doing that. And there are other mines close by which are treating the brine in order of other coal mines, which are their brine is being treated in order to recover clean water and salt. In this case, coal mine water is going to be processed with nanofiltration to recover magnesium hydroxide, with reverse osmosis to recover fresh water, and electrolysis and crystallization to recover the salt. In comparison to that wastewater treatment plant, which treats brine of other close by mines, the consortium managed to decrease energy consumption by 50%, and as a result, you would expect environmental benefits only due to that, and also to recover faster processing times, and also to recover salt or concentrated brine and magnesium hydroxide. And then finally, in the Turkish textile plant, reverse osmosis retentate or reverse osmosis concentrate, the same, is going to be oxidized with ozone, and then nanofiltration and reverse osmosis are going to be employed in order to remove impurities and to recover fresh water respectively. And then an ion exchange unit is going to recover a solution rich in sodium chloride. In this case, again, like in all the other cases, the fresh water is aimed to replace feed water, and then the sodium chloride or the recovered brine can then replace salt that it is used in textile dyeing. So from the Dutch case study, the recovered materials result in significant ecotoxicity benefits for that location, economic benefits if the recovered minerals and water are of high quality, and social benefits because of the reduction of imports of Russian magnesium hydroxide, because, as I said, it's a high conflict mineral and European Union wants to reduce this kind of minerals in the consumed in Europe. In general, from the project, one would expect less toxic ports with greater biodiversity benefits and financial benefits. In Spain, there is a large potential of financial benefits and a significant decrease in water use. In Poland, there are high energy improvements and potential financial benefits, and also reduction of high conflict minerals. And then finally, in Turkey, there can be environmental benefits due to the avoided products and especially the water. As I mentioned earlier, there are the BRINE Excellence Centers, which were built due to the project, and these centers are going to demonstrate technology that was used in each case study, but then they're going to include more technologies and also analytical equipment. The main BRINE Excellence Center is located in the Netherlands, in TU Delft, and there are other 4 satellites BRINE Excellence Centers in Poland, in Spain, in Greece, and in Italy. And in the brackets, you can see the organizations, universities or institutes which are in charge of those excellent BRINE Excellence Centers. And in each case, in each country, companies can take their real brine, take it over there and then analyze to see what kind of materials, what kind of minerals, what is the composition of the brine, and they can even do some tests in order to see which of those materials can be recovered and which of them is financially beneficial to recover. And a few words about some follow-up projects. There is the live brine mining, which focuses, and this is my last slide of this part, and which focuses on treating brine from another Polish coal mine. It's one of the coal mines that already has that wastewater plant that I mentioned operating in order to recover clean water and salt. And this was funded by Life for 6.3 million euros. And then there are 2 big Horizon 2020 projects, which also started like the Live Brine mining project in 2020, earlier this year. And the first is water mining, and the second is called C for Value, and they have a budget of 19 million and almost 7 million euros respectively. And with this, I would like to, I finished my part. I don't know, Case, if there are any comments, any questions so far?
No, I haven't seen. Oh yeah, there's Peter, maybe you would like to ask yourself. Please step in if you want.
Yes, hi George. Can you hear me?
Yeah, clear, thank you.
Good. Hi, my name is Peter Wessels from L Utilities. I have two questions really. The first one is about the Poland case study, where you said you managed to reduce the energy input by 50%. And I was wondering what the baseline technology was that you compared it with, because yeah, that's quite interesting.
Yes, so for that wastewater treatment plant, there were 2 technologies. The first one was evaporation, not evaporation, sorry, it was, I'm missing the word.
MVR?
Not MVR, mechanical. So they were condensing, anyhow, they were condensing the brine with removing some water, clean water, which is disposed to the river close by, some distillate, and the second one was crystallization, where they were initially removing some gypsum and some lye, and the gypsum was also used internally by the coal mine for safety purposes. And the lye in that case, LYE, lye, it was also used for avoiding ice on the roads. And then they were drying the remaining in order to recover clean water again and salt. And in that case, the salt, they were even able to use it as table salt, to sell it as table salt. So these were the three technologies. Yeah.
Okay, thanks. And then the second question sort of relates to that is if the more you concentrate brines, typically the more energy it tends to cost. And for me, it feels like there is a sort of optimum environmental impact between recovering as much as possible water and potentially valuable minerals, but also how much energy you put in to such a system. So is that something you're also looking at in this project?
So what exactly do you mean? If we are searching for the optimum
for the optimum environmental impact, basically. So what I said before, the more you concentrate your brine, the more energy it typically costs to treat it, and that there's a sort of optimum between how much environmental benefit you have from recovering more water and recovering certain specific minerals, and how much energy you put in, which relates to CO2 footprint and other things.
Yes, that you are correct in that, because from the beginning we were in discussion with the partners who were involved in the demonstration units, the operation of the demonstration units, in order to initially make a preliminary assessment, environmental and economic assessment of what is expected from the case studies, from the demo units which were going to treat the real brine. And then based on the results, we contacted them, and then we had discussion about environmental hotspots. And yes, in order to decrease certain materials, for example, that were used in some stages by some processes. And for additionally, next to that, it's also important we found out that it's also important to recover some of the recovered materials to be of high quality in order to have a market for them, to be able for the companies or whoever is going to be in charge to sell them and have financial benefits. Does this reply to your question?
Yes, thank you.
Thank you.
No other questions. And indeed, I think it's also the end use of the minerals that really define how far you should go till a solid or a slurry, which concentration.
Exactly. And I think we're almost in the middle of the webinar, and there was no break until now. Now it's also time for the first break. So we're going to be back, Case, in around 10 minutes.
That's okay. So 5 past what is it? 2:30. 2:35.
Okay. So see you in a while.
Yeah. Start slowly again. Hope people had possibility to take a drink.
Regarding the previous question, I checked, and for that wastewater treatment plant of the coal mine, they treat brine with firstly it is mentioned as described as brine concentration, but distillate is produced, and then there is a lamella clarifier where more solids are removed, and then it's the crystallization and the drying process where salt and also gypsum and lye are removed, and then they're also in ponds separated from the water.
Okay.
And yes, regarding that.
So if someone still would like to discuss something from the previous presentation, Gijsbert or Jan Willem, or what George presented, feel free to ask question now or in the chat. We still have some time later on to discuss these things, so feel free to ask your questions or put something forward. But if not, then George can continue. Thanks.
Thank you. So the next part focuses on the online BRINE platform. And the online BRINE platform, I will describe later what it is, of course. Oops. Let's see. Yeah. So there are different circular business models, other that focus on circular supply chain, on the recovery and recycling of materials, on extending the product life, or even considering product as a service. And in this case, the consumer is not the owner of the product, but the manufacturer is the owner of the item. Let's call it the item that the consumer is using. And you can think of it as in the Netherlands, there are some bikes that people are basically not buying, but it's like renting them. So they pay a specific fee every month. And then if something happens to the bike, then the company has to do the maintenance. Next to all of these models or concepts, there is also the sharing platform. And in this case, platforms can be used to promote or facilitate renting, swapping of resources, and to connect different corporations, different stakeholders in order to initiate, to promote collaboration among each other. Such a sharing platform would allow multiple users to use similar resources or byproducts, and as a result, reducing the demand and reducing the use of raw materials, of virgin materials. And the online BRINE platform is a sharing platform that is aiming to do this, specializing on brine. The online BRINE platform, as a result, is an active web service which aims to promote the flow of secondary raw materials by linking brine owners or brine producers, and I will call brine producers brine owners from now on, then minerals and water end users, technology providers, and waste heat providers. It is important that when someone is registering to the platform, that sensitive data is protected, and this is taken into consideration when the platform was designed, and there is data that is mandatory when somebody is registering is registering to the platform, is creating an account for the first time. And there is also data which is mandatory when somebody is going to input data regarding the brine that the company is producing or the minerals and end users that are relevant. Therefore, this part regards a detailed presentation and know-how about what kind of information is expected when somebody is going to make an account, but also later what kind of data is expected and what would be useful in order to create these synergies, these symbiotic relationships among different platform users. So next, there is a tutorial which was recorded by National University of Athens and Revolve Media, and focuses about the registration process and some basic steps later on. So let's see first this, and then I will continue with a more detailed presentation.
The online BRINE platform is an interactive matchmaking platform promoting synergies between value chain industries, thus furthering industrial symbiosis, resource efficiency, and circular economy. The online BRINE platform matches BRINE owners that can offer untreated saline streams or those already recovering materials with BRINE reusers such as mineral or water users, as well as waste heat and technology providers. To register to the online BRINE platform, go to zerobrine.eu. Under the project menu, select Online BRINE Platform. On this page, you will be presented with two options, to log in and register. First-time users will need to register. To register, first create a username, secure password, and an email address. The user can choose to register with only a username and a password, in case they want to keep their profile hidden from others. For users that register their industry name and location, their identity is revealed to other users only after they consent, or when they have been matched to another user. You can add your company or industry name, and for companies based in the Netherlands, you can designate a specific industrial cluster. You also have the option to add an NIC code, or National Classification Code, and your company's website. You can add your company's address, with the option to make your company's location visible to other users. This can be helpful for forming symbiotic relationships with other industries close by. Lastly, you can add an NACE code. Once you agree to the terms, your registration will be complete. You will receive a confirmation email with an activation link in order to log into the platform. To ensure successful matches on the online BRINE platform, we encourage all users to complete their profiles with the requested data. Incomplete profiles can lead to uncertainty for other users, lessening your chances of being matched. For users that only register with a private profile, you can update your profile information once logged onto the platform. To begin on the online BRINE platform, select your user role as a BRINE owner, end user, waste heat provider, or technology provider. You can have one or more user roles. To register as a BRINE owner with untreated brine streams, you will need to add your saline effluents and their characteristics, as well as the materials to be recovered and their characteristics. If recovering materials, you will need to specify what is being recovered with their quality parameters and information on the recovery process. As an end user or mineral or water user, you will need to select the required materials, their uses, the quality required, and any additional parameters required for minerals. As a technology provider, select which technology you provide for treatment of saline effluent. As a waste heat provider, select your waste heat type, its temperature, pressure, flow rate, and flow rate variation. Once you have filled in the respective data, on the side menu, a Suggested Matches tab will appear. Level 1 matches are good quality. Other matches will also be recommended, even if quantity of resources is limited. You will then be allowed to message these users directly. In addition to the online BRINE platform, the online BRINE portal, which is also accessible at the bottom of the online BRINE platform webpage, is an additional resource to support technical aspects of brine stream and valorization opportunities. Consult the online BRINE portal should you need information or support on the following: brine streams generated by process industries based on scientific and BREF documents, industrial uses and properties of minerals based on REACH regulation, or descriptor categories such as nomenclature of economic activities, European waste category, product category, technical function, article category, or sector of use.
So, the next part consists of a detailed presentation of what can be achieved and what it is, what kind of data is asked or required to have good matches in the online BRINE platform. It is quite detailed, so I will try to show every aspect of it. So please interrupt me during the presentation if you have any questions about it And I will stop sharing my PowerPoint screen and then go to. So I already have an account in the platform, so I don't need to register. So then I will log in. And maybe this is better. And here you can see that on the main, in the main big part of the screen, we see how many total users currently exist, how many matches exist, what kind of effluents, what kind of recovered materials, required materials, technology providers, and waste heat providers. On the left side, there is the option for the dashboard, the role that I have, searching the platform and its users, statistics about the users, messages, notes, etc. And I will go to each different option step by step. So let's say that I produce brine. This means for the platform, I'm classified as a brine owner. And in this case, I can either generate the brine or I am a company, I'm part of a company that aggregates different brines. Let's say, for the matter of discussion, for the sake of discussion, that I'm generating brine and I press update. And then the platform is going to ask me about adding my brine qualitative and quantitative information, but also it will ask me if I'm already recovering materials from my brine. Let's go in the first step, and here you can see this is the identifier. It's my name and effluent 0. It will ask me about how much is the brine that I'm generating on a daily basis, on a monthly basis, the total dissolved solids, chemical oxygen demand, biological oxygen demand, the NACE, the economic activity, European economic activity coding, which is also based on what kind of code I have inserted during my registration. In this case, only the monthly flow and the total dissolved solids is compulsory information. So let's say that I am generating 1,000 cubic meters of brine every month with a total dissolved solids of, let's say, 1 gram per liter. If I try to select next, I will get an error stating that in this case, for the total dissolved solids, there is a minimum limit of 2.5 grams per liter. So then I have to go and change it. Let's replace it with 10 grams per liter. And then I can also add information about what kind of activity, what kind of company, what kind of waste do I produce. Let's say that I am part of a company that it is extracting coal. So then it would be 01, and you can see that the coding was added here. And then I can make it even more specific. Let's say that this brine is waste from mineral excavation process, so 1.01, and then non-metalliferous excavation. I can also add more effluents, but let's say that I'm producing brine only from one site or from one process, and this is what I have right now. So if I press next, the platform will ask me 2 questions, or will give me 2 options. If I already know what materials can be recovered, or if I'm interested in which materials can be recovered based on the brine composition that I have. So let's start from the second. Let's say that I know the brine composition, but I am not certain about what minerals exist in my brine. So let's say that, okay, I have 100 grams per liter of chloride and the same amount of hydrogen. And let's say for calcium, I have these three anions and cations. So these three elements, chloride, sodium, and calcium. Since I don't know what kind of materials can be, what kind of minerals exist with a combination of those elements, then I can ask the OBP to tell me what. And based also on my monthly flow and the concentration of the elements, then the platform is telling me, is showing me how much, what are the quantities or in grams per liter and in kilograms per month. And then in this case, I can select, or I can say, try again because I missed something. You see that the information, the data that I have inserted is not lost. And let's say there is also potassium in my brine and propose materials, minerals. I would still, let's say, for the sake of the example, go for the first two. And let's say at the same time that in this hypothetical example, I also know what kind of materials exist in my brine and I can recover. And then for effluent 0, still the same brine source. And if I click here on the materials, there is going to be a drop-down list with all the materials that exist in the platform, and it is a lot. A lot of them is mentioned. The only thing that I have found that is not mentioned, if I go to the one or the second option, is the water. So in this case, let's try and make a combination from both. And let's say that I already know that I have water that I can recover, or I'm interested in recovering. And I'm not going to add any materials here, but I'm going to leave this as it is. And in this case, the platform will combine information from both options. However, as I said earlier, you can only include one of the two, and then it's the same. It depends what it is known from the user. And then we can see for this brine source, 0, I have this concentration of sodium chloride, this concentration of calcium chloride. This is my monthly flow. I have inserted it earlier, and this is my water flow. And it asks me for a flow per day. So let's say if it is 1000, let's say, just for the sake of the argument, let's say 10 cubic meters per day. And then I press finish. And now I have finished adding saline input, and saline effluents have been added successfully. I get the message, and I can even press here in order to provide some feedback to the platform. If I go to the left side, then I can see my saline effluents here, and I can modify it. If I press here, I'm going to modify the information that I have already given, and I can even delete them. Furthermore, if I want to add more effluents, I can go to add effluents, and then should be number 1, and this is a different brine source. So earlier we saw that the platform is also going to ask us if materials are already being recovered. And in this case, I can go to add recovered materials. There is a drop-down list again. Let's say, since I know I have inserted that there is water, calcium chloride, and sodium chloride, let's say it is, I will also add these 3 materials, and I will say that I as a company, already have the technology to recover them. And I don't have, even though I found it here, I don't have necessarily to search for it. I can also write it down and then it will filter out the rest of the materials. Then I will press next and go to the quality parameters. So these are quality parameters for recovered material. 1, water. As you can see, there is no asterisk here, so nothing is mandatory. Let's say that I don't have any information. I only know about the pH, that it is somewhat basic, let's say 8. And then for sodium chloride, let's say that I know the expected purity. Let's say I know the purity that I expect is 99.5 and the moisture coated is 0.2%. And then for the rest, total organic carbon or heavy metals, I don't know. Something similar for the calcium chloride, let's say that the purity is 65% with a moisture content of 10% will be very probably low, let's say 30%. And I can go on the bottom and press next. So in the next stage, the platform is going to ask me what kind of technologies are employed in order to recover these materials. And here on the right side, there is an entire list of all the technologies which also belong to the technology providers. Let's say that I'm using some kind of crystallization method and also evaporation. Let's see, forward feed, evaporation. The platform will also ask me with KU for economic data, capital cost, operational cost, which again is not mandatory. And then it's going to ask me about environmental data, the functional unit, in case an LCA study was employed. And this case is also quite specialized, very specific data, which is not going to be, yes, which I think most of the accounts, most of the users don't know this information. However, Jan Willem earlier presented that for Evides Industriewater, they are performing LCAs. So if other companies have performed LCAs, maybe this is known. And then LCA indicators. So basically, these are environmental impact results. And in LCA, the environmental impact results are presented per functional unit. This is also why the functional unit is asked here. The functional unit is the functional flow of a system. So if a system is aimed at producing, for example, ultra pure demineralized water, then the functional unit can be 1 cubic meter of ultra pure demineralized water produced in the plant, and then all the environmental impacts are going to be presented per 1 cubic meter of water. So let's say I don't know anything of this and I will press finish. At this point, I have, as a brine producer, brine owner, my saline effluents and my recovered materials. And I can add more recovered materials or modify the existing ones. Let's say, however, and as you can see below the my role, between the my role and search buttons, there is a suggested matches, and I will discuss a bit later about the 2 levels of matches when I will discuss, I will show about the end users. And for this reason, let's delete everything in order to change my role. I don't know if there is anybody who wants to ask something specific about this process of
I did not see any questions in the chat, but if someone has a question now, please feel free to ask.
It's a quite detailed tutorial.
It's a training session.
Yes,
I
so
have a question, if you don't mind.
Yes, please.
of course.
So really interesting, this platform, but one of the things you showed earlier is once you add a brine, then you can select which products can be recovered, right? There was this
Yes,
tool
if it
where
is
you
known.
there was this tool where you filled in calcium and magnesium and some other things, and then it suggested some things to recover. But why would you not select all the potential stuff to recover from that brine? Is that...
Yeah, I think I selected all the potential. So this depends on the composition of the brine.
Mm-hmm.
So in this proxy, I said that I have only these three materials, and the rest can be water. So it depends on the composition of the brine. So and depends on the process that's producing the brine, the feed water, etc.
Okay. Yeah. So that, I guess that was my question. Was it makes sense to always select all of them, right? Because then if I have a brine and I don't know what the value is, then it would be really nice to get a match with any potential end user.
Mm-hmm.
Whether
yeah, that's true. Can be done. That's a way to go. Yes, that's true. Yes, interesting. Yes. However, yes, if you would like also to know more information, maybe also the Brine Excellence Center can be used for that. So you could take your brine to them to analyze it. Then you will know the composition, and then you know what materials, what elements to add to that step, and then select, like you said, all the potential materials.
Okay, cool.
Yeah. Okay. Thank you, Peter. I guess. Is there any other question or?
Not in the chat.
Not for now. So let's say that I'm a mineral or water end user. So for this step, for this role, I'm going to insert what are my minerals that I'm using as feedstock. Let's go again for the same, for the like in the previous example, and calcium. And then in this case, it will ask me about quantitative and qualitative information. First, it's going to ask me if the water and sodium chloride and calcium chloride are being used from one process or from more. And the more processes that exist, the more water uses I'm going to have, and more water flows are going to be required. For the sake of discussion, let's say that I have one process that is consuming these products. So let's say this is going to be used as water for steam generation. And then the identifier is water number 4. And then the flow every day is 10 cubic meters. And then for the sodium chloride, there is going to be, again, it depends if it's more than one processes. Let's say for every mineral and water products, it is one process that it is consuming them. And then I use 10 kilograms per month. Okay, 100 kilograms per month seems more realistic. And then the platform is also going to ask me about more qualitative information with respect to the sector of the end use, the product category, article category, and technical function. So if I click here again, there is a drop-down list which contains everything. So that means that if you select mining, the product categories that are going to appear are not going to be different if somebody is going to select another sector of end use. But let's say that I don't want to provide any more information. I'm only providing at this stage only the less amount of information. And yes, this is an error from the platform because I had selected calcium chloride, and I don't see my calcium chloride here. Also here, okay, that's interesting. Then I will press next, and then again it will ask me the platform more information, which again it's not mandatory for the water that I'm using, for the calcium, sodium chloride, and sodium hydrogen carbonate. Let's say that I don't know anything. Well, we can say about the sodium chloride that I know a few things. Let's say in this case it's 95% with 3% of moisture, and I don't know the rest. So let's see if we are going to get better matches. And also for this, although here calcium chloride is mentioned, and purity again 65% with 30% of moisture, and press next. And then it's going to ask me more information about the two minerals, sodium chloride and calcium chloride. Let's say I don't know anything more. And then that part finished. Again, on the left part, I can see my required materials. So what materials my company is using as feedstock. I have this, I think I had inserted it from in another day, so that remained. So 2 flows of water, and yes, I have more information and more materials. This I didn't delete them from another webinar, but then it is good because maybe we get more matches, because here I had inserted that I'm also requiring sodium chloride, but lower quantity on a monthly basis, and also magnesium chloride. So let's see in the matches, which are match 1, level 1 and level 2. And level 1 depends on the kind of material, the location that the two corporations, that the two companies exist, and also on the quantity of the required materials. And level 2 adds another aspect of this on the quality of material, so based on the qualitative characteristics like pH, purity, etc. that I have inserted. So let's see for level 1 if there are any producers, brine owners. So we can see that there are several brine owners, and there is sufficient quantity in all of them. And then the platform is giving me a couple of actions to do. First, I can give consent, and then here it shows that I have given consent to NTUA user to get my sensitive information, because up to now all my sensitive data, like what is the name of my company, where my company is located, etc., is not visible to other users. And if I also get consent from them, then I can collaborate, hopefully, with each other. I can message him. This can be done for everybody, but now I can message somebody specifically because I have level 1 match with him, and I can even check details of the materials that I said that I'm requiring, and the materials that this brine producer is generating and he's able to recover. This is level 1 match, and level 2, if next to the quantity kind of material allocation, I'm going to add the quality of materials, then I'm going to have again different, probably less matches. So in this case, I can give, for example, consent or not, and I can see the details of the BPB calcium, sodium chloride that is recovered. So I'm asking for 100 kilograms per month, but this brine producer is having a much bigger amount with a much higher purity than what I am asking for. So in that case, and as you can see, they haven't inserted any economic indicators with respect to capital cost or operational cost. And in this case, I can go back and I can give consent to this brine producer, and then if he also gives consent, then we can contact much better with each other, or I can just message him right now. So regarding these two roles, matching opportunities exist. And then if I go to my required materials, then I can start deleting in order to change my role. And then also avoid confusion with brine producers who have inserted characteristics about their brines and the recovered materials of their based on their brines. And then I can change the role and I can go to the other two more straightforward roles. Oops. Which is the technology provider. And here all the technologies that were presented earlier are going to exist. And again, there is a drop-down list. It also classifies them based on certain characteristics. So organics removal, brine purification, brine concentration, and brine crystallization. And all of these technologies, or at least the majority of them, are also involved or exist in the brine excellence centers. So if anybody interested, they can contact relevant project partners. And if I add something, let's say nanofiltration, and if I save it, then it will exist in my technologies part. And similarly, if I go and finally change my role to the waste heat provider, I'm going to add a few characteristics of the kind of the waste heat. So let's say I have flue gas, heat derived from flue gases. If I'm already using part of that heat, when the flue gas, when the flue gases, they exist at a certain point of my company, that they can be used by another guy, by another corporation, let's say, that is at 150 degrees. It is, the pressure is 1 atmosphere, and the flow rate, and also the variation, the range of the flow rate, because the flow rate of the flue gases, they may range during the day and during the night, or between weekdays and weekends. So these are the 4 distinct roles that exist in the platform. I don't know if you think that these are enough. I also have prepared a brief questionnaire, which is going to be presented later on, before we wrap up everything. And other things that I can do in the platform is to search for technology providers, waste heat providers, BRINE users or end users. So if I go to the technology providers, for example, I can filter it out based on the technology, and I can see different corporations, different stakeholders, and the technologies that they can provide me, and with the waste heat providers the same. And regarding saline effluents, here there are of course more information, and I can filter them by material. The same for the required materials. And if I go to the user by role, I can yet again filter everything based on the different roles, one or more. I can search, I can ask to show me more than 10 entries per page, etc. If I go to the statistics, I see based on the registrations how many of them they come from the different Dutch industrial clusters, how many matches exist and what is the matching rate, and how many are the matched users. Other statistics regard the waste catalog. You remember when I started inserting relevant the codes, selecting the codes for the waste, and my example was that I'm a company that I'm producing coal mine brine, and then also based on the next code, what are the different what is the different rates, what are the variations of the users that have registered. Next, there are the messages. I haven't received any message. My notes, announcements from the BRINE, administrators, the BRINE developers, and also frequently asked questions, which again, you can find details about some of the most frequently asked questions. And then there are also links about the online BRINE platform portal and the Zero BRINE project. And with this, I think this is more or less everything I wanted to show about the platform. Case, I think there are no questions.
No, I haven't seen questions in the chat. I think you also got very detailed through the possibilities of the platform, so it's very clear. And still there are more possibilities, so it's a very extensive platform. But yeah, I guess also very nice to get possible matches for, in the end, industrial symbiosis and exchange of nutrients or heat. The technology providers, you can find them over there, so very clearly explained. But if there are still additions or questions or remarks, feel free to add them. Or if you see links to the previous presentations or have questions or doubts about something, let us know.
Then I think, shall we have a 10 minutes break and then come back with a discussion, with a questionnaire about the platform and potential discussion around it?
Yeah. So let's have 10 minutes break. Then we meet again at 3:30.
Perfect.
Okay. See you soon.
See you later. How we can do, let me first, I guess, share my screen. It's time for the questionnaire about the online BRINE platform, but before that, I would also like to ask something, Jan Willem, if it's possible, one question from your presentation.
Yes, I'm here. Was a question you said?
Hello, Jan Willem. Yes, this is George. So the question is about, you showed the slide about the circularity, and I can show it again if you want. It's about the reuse of water in Dow, and you also said about Lamp Weston.
Yes.
And my question is, if you can share with us, how exactly does it work? Does Evides selling the equipment to these companies and then they are in charge of their wastewater, or you own the equipment and then they are paying you a certain fee, let's say, to process their wastewater? So, because I also showed a couple of business models here, so I was wondering how exactly, if you
Yeah,
can share with us, if it's not confidential.
in the situation of Western, the company owns and operates their own wastewater treatment. So we don't play a role in the wastewater treatment activity, but they deliver the effluent treated wastewater to us, and in our own facility, on DBFO basis, we treat that water further to produce demineralized water for them, and we deliver it back to the company. So the reuse plant is owned by us and operated by us.
Okay.
In the situation of Dow, we have the domestic wastewater reuse. So we take the water from the water authority. It's basically a combined installation. That means that the water authority, they needed an extension of their wastewater treatment plant, and normally they will do it on a conventional way, but together we build a membrane bioreactor. So the membrane part is owned by us, the biological part is owned by the water authority. We operate the plant, and the water is transported to our own demi-water production facility, which we also operate and own and operate. Is that enough answer for your question?
Yes, thank you very much. Yes.
Welcome.
I was wondering, and yes, I got this question during your presentation. Thank you very much. So far we have seen what industrial symbiosis is, some successful circular cases and attempts and plans in the industry, and by Evides also, by Evides Industriewater in the Netherlands. And then the Zero Brine project was presented and the online Brine platform. And I understand that was quite a detailed know-how tutorial about the platform, but I have some questions for you, if I may share the poll. So I don't know if you are already if you have already registered to the platform, or if you took a look during this 10 minutes break. But I wanted to ask you a couple of things about satisfaction with the current matchmaking capabilities. So basically level 1, matching, and level 2. And to remind you, level 1 concerns the location of the companies, the kind of materials and the quantity of materials, and level 2 adds to that the quality of materials, so qualitative characteristics. The second, if you are interested regarding these characteristics of your own brine streams, to register them in the online platform. And similarly, if you are interested in registering quality characteristics of minerals employed at your facilities on the online BRINE platform. And the next, about the minerals. Do you think they are enough? Do you think something should be added? If you have, and especially the last two questions, which are a bit more open, if you have any considerations or reservations regarding registering your brine or mineral streams in the online BRINE platform, and if those reservations exist, why? And there are some replies that might be useful. And if you think that the platform can be improved to make it more efficient to reach this industrial symbiosis in the Netherlands, but also in Europe, because after the showcase of the online BRINE platform in the Netherlands is going to extend and then potentially cover all Europe, and then everybody can register. And since location is taken into account, then we can see, we can check for matches.
So some responses are coming in. That's very good. If people would like to add to the responses, you can use the chat. For example, someone mentioned that more minerals should exist in the online BRINE platform list. So please add in the chat if you miss a certain mineral, or if you would like to provide more information. You are more than welcome, of course. And I also see some information about the sensitivity. So George, you showed that data can be inserted into the online BRINE platform. And you only release it if you give consent. So if there's a match, then you give consent.
That's true, except for the username and the email address that it is going to be used to create an account. So these are the only two. These are the only two data that I can imagine that in some cases the email address can also contain sensitive data, because some people, they create webmails with their real names or with yes. So I can imagine that even if somebody doesn't use his webmail from so the business webmail, when usually our first name or the initial of our first name exists and then our last name, if somebody doesn't use this and he uses his own personal email, but then in some cases also personal emails may contain sensitive information. So maybe this is a thing to change in the future when somebody registers in the online BRINE platform, and only the username would be visible to everybody.
Yeah. It's good to know these kinds of improvements that are still possible, of course. So if people have specific thoughts about that, please share. So there is in the chat a comment. Would you like to bring that forward yourself, or otherwise we read it from the chat? Peter?
Yeah, it was me again. Sorry.
That's good.
No, so I'm thinking more from the perspective of we're doing a lot of consultancy work for customers and doing reuse studies and water saving studies, and quite often when it comes to the point of a brine, then it's like, okay, now how far do we concentrate, and then we have this brine, and what are we going to do with it? And I think the owner of that brine typically does not really know if there is any value in that brine and what that value is. And it would be nice if you could just add the brine with some high-level quality details, and then you would get a sort of advice on, hey, this is potentially interesting to look at these and these type of minerals to recover, or something like that.
Yeah.
Thank you. So do you mean, can I ask something, Kees?
Yeah.
So do you mean, Peter, for example, to when the platform is going to propose, let's say, minerals, if we add next to that potential financial value of those minerals, depending also on quality, so maybe there can be a range. Something, you mean something like that would be beneficial for the brine producer to understand what can be achieved, what can be, what profit to expect.
Yeah, exactly. Or at least to have an idea also of what kind of investment they can do, and justify that by some payback value.
Okay, thank you. That's interesting.
Yeah, I think it can also be quite difficult because
yeah, I get that.
of course, that you put in some details of what's present in the brine stream, but still it depends also on other contaminants or constituents, other particles in the stream that need to be removed to get a product that is usable, can be used by another organization, and preferably close by, because if you have a lot of transport, then also the financial feasibility will be maybe less possible. So I think it's interesting question, but quite difficult.
Yeah, or maybe what you mentioned earlier, George, that you have this test center. Indeed, if you could send a sample there, and they could give you a recommendation based on available technology.
Yes, so to have also a better link between the Brine Excellence Centers and the online Brine platform. Yes.
Yeah, and I don't know how well that is organized already, so I haven't really spent a lot of time on this, but that's just one thing that popped up in my mind.
Yeah, thank you.
Yeah, I think it's also a possibility of the Zero Brine project that with these test centers and the online brine platforms, there are different opportunities and possibilities to find circular opportunities and uses of so-called waste streams, brine streams, because there are possibilities, and it's good to explore these.
No, so that's why I find this really interesting. So thank you very much for your presentation. I'm definitely going to follow this, and if we have projects, definitely check in if there are potential end users for specific minerals or something like that.
Yeah, perfect. I will end the poll shortly. For a while, we didn't have any more replies.
Some people
let's take
in the poll, and it's good to see that there are a lot of people satisfied with the current matchmaking capabilities, and some people are also interested to register also their own brine streams if they have, because if you don't have a brine stream, you can't register the brine stream, of course. So that's good to see. You want to go through the results, George, or what's your?
I can, yes. So 3 out of 5 are interested in registering minerals employed in their facilities at the online brine platform. It's interesting that more people are interested in inserting quality characteristics of feedstock than characteristics of brine streams, but maybe compositions of brine streams are not known. This can be also the case.
Yeah, and I guess also maybe not everybody has a brine stream, so.
And then quantities of minerals employed. Then it's again the same like the brine streams. 60% are not interested. And the next would be about minerals which are not covered by the platform yet. So the majority replied no. One person is interested in minerals that are not covered. So if you would like to tell us, to let us know which mineral this is, we can ask the moderators, the administrators to add it. Because ISPT is not the administrator of the platform. National Technical University of Athens is the administrator of and the designer on the platform in the Zero Brine project, and they will continue doing this also after the end of the project. Regarding considerations about registering brine streams or minerals, there are no considerations by the majority, and then there is sensitive information which cannot be shared, or information that needs to be permission is needed by the manager first of that employee. I guess this regards feedstock, minerals used as feedstock, probably not brine streams, if the person can confirm it. And here there is something interesting and controversial, because earlier it was replied that where is it? That the matchmaking capabilities of the platform are good. But then here there is a reply that matching opportunities are not adequate. That more minerals should exist in the platform. Yes, which are that? I personally didn't go now to check every mineral. It is a quite thorough list. I can imagine that there are more, of course, but then considering in the elements that can be included, the anions and the cations, which exist in the brine or which consist the brine composition, I expect that all the potential combinations to be there. And then the platform, 3 people say that the platform cannot be further improved. That's good, but yes, if still something can be done, we can forward the information. I don't know if you would like to add something.
Yeah, if someone has any further comments or thoughts about this, feel free. And I guess also with the matching opportunities, maybe also with the finances that we also discussed, that's still something that's not in the matching directly. Could also be the case. But otherwise, I think this is okay. We can continue and almost finish the training session.
Yes, let me close this. And well, this is what I wanted, what we organized for everybody today. Discuss, present the industrial symbiosis, circular economy in the Netherlands, a little bit, just give a very brief overview, especially with the guest presenters Gijsbert Korrevaar and Jan Willem Melder. And there is something.
Yeah, it was me in the chat. I thank also everybody for the attention.
Yes.
And
Then about the Zero Brine project, very brief description. The project started in 2017. I didn't mention that. There was, as you can imagine, there were some problems due to the coronavirus and the demonstration activities, the demonstrations. So there is an extension until the end of this year. And some of the deliverables like the online BRINE platform and the BRINE Excellence Centers are going to continue existing after the end of the project. You can contact us, contact Revolve Media if you are interested about people who are in charge about the BRINE Excellence Centers in the Netherlands, in Poland, Italy, Spain, and Greece. And yes, I don't know if there are any last minute comments. If there are not.
not in the chat at least.
From our side, there is going a questionnaire is going to be sent and also a form if you would like to evaluate this webinar. I would ask you, everybody will be very welcome if you can also fill the questionnaire about the online BRINE platform. Take a look, see if you have any difficulties in registering, take a look, see if you think there is something's missing. Maybe there are some big problems that we haven't anticipated, and yes, do let us know if you can provide us with feedback about the online BRINE platform. And that's it from my side. Thank you, everybody. Thank you, Kees. Thank you, Gijsbert, Jan Willem, for helping, for presenting. And also Daniela and Josh from Revolve Media for the organization of the webinars. And also everybody for joining.
Yeah, and thank you, George, for presenting and bringing everything together. And thanks to everybody for joining indeed. So see you later. And if you still have comments, let us know.
And everybody be careful and stay safe.